Learning ARM assembly can be an enriching experience, especially if you're interested in embedded systems or low-level programming. Here's a structured approach to get started. 1. Understand the basics of computer architecture. Before diving into ARM assembly, it helps to have a basic understanding of computer architecture. Topics like the CPU registers, memory hierarchy, and instruction sets will give you a strong foundation. Resources, computer organization and design. The Hardware-Software Interface by Patterson and Hennessy online courses on computer architecture, e.g. Coursera edX. 2. Get familiar with ARM architecture. ARM Advanced RISC Machine is based on the RISC-reduced instruction set computing architecture, so it's important to learn about its specific features. ARM instruction set. Learn the differences between ARM and thumb instructions, as ARM processors often support both registers. ARM processors have 16 general-purpose registers, and knowing how to work with them is key resources. Official ARM documentation. ARM Architecture Reference Manual. ARM developer website has excellent tutorials. 3. Choose a development environment. You'll need an environment to write, assemble, and simulate your ARM code. QEMU, a powerful open-source machine emulator that supports ARM emulator, like KileMBK, which is useful for embedded ARM development. GNU Assembler JS, part of the GNU toolchain, commonly used for ARM assembly development. Setting up QEMU along with an ARM cross-compiler, like ARMany BGCC, can help you emulate and run ARM assembly code on your local machine. 4. Write basic assembly programs. Start with simple assembly programs to get a feel for the syntax and operations. Arithmetic, addition, subtraction, etc., logic operations, and/or XOR, conditional branching, looping constructs. ARM assembly instructions are generally simple and follow a fixed format, making it easier to learn compared to more complex architectures. 5. Study ARM assembly syntax. ARM assembly language has a unique syntax. The following basic structure is important to understand. Instruction. AG80 R0 R1, R2 as the contents of R1 and R2 and stores the result in R0 operands. These can be registers, immediate values, or memory addresses. Condition codes. ARM uses condition codes for branching and executing instructions conditionally. Resources: ARM assembly language programming by William Hull. Tutorials on websites like AzureLabs.com. 6. Learn debugging techniques. Debugging is a critical skill when working with assembly. Use tools like GDB GNU Debugger, useful for stepping through your assembly code. ARMDS5 Debugger provides advanced debugging features tailored for ARM development. 7. Work on projects. Apply your knowledge by working on small projects like writing a simple calculator in assembly, implementing basic data structures like stacks or queues, writing programs that interface with hardware, if you have an ARM-based microcontroller. 8. Join communities and explore open source. Learning from others is one of the best ways to improve your understanding. ARM developer forums, Stack Overflow, for asking questions and resolving issues. GitHub repositories where people share ARM assembly projects. By following this roadmap, you can gradually build your skills and gain a solid understanding of ARM assembly programming.